Okay, 6.6 day 3, we're going to solve logarithmic equations today. Okay, so first we're going to look at the property of equality for logarithmic equations. Okay, let b, x, and y be positive real numbers. So we're going to have a positive base here, we're going to have a positive argument here, with b not equal to 1. If the log base b of x is equal to the log base b of y, then x must equal to y. So if two logs are equal to each other and they have the exact same base, then they must have the same argument, which makes sense. Remember, IFF means if and only if. It's an abbreviation. The one thing to keep in mind on logarithmic equations is that the x and the y, or the arguments, they have to be positive. So occasionally you'll get a solution that makes it so the argument is not positive, in which case it would be an extraneous solution. Okay, so let's look at example 1. I have the log base 5 of 2x plus 3 is equal to the log base 5 of x plus 8. They are both log base 5s, and they're equivalent to each other, so it must be that this argument is equal to this argument. So I'm going to go ahead and set them equal to each other and solve for x. Okay, and your algebra steps could be what they are. I'm going to minus the x over, should I minus the 3? I'll minus the 3 over also. Okay, so I get x equals 5. Okay, now you need to check for extraneous solutions. You don't have to check as completely as we did for radical equations. The main thing is to make sure that the argument is positive. So if I plug 5 in here, 2 times 5 is 10, 10 plus 3 is 13. That's positive, so it's going to work. If I plug in 5, 5 plus 8 is 13. This argument is positive, so this is a valid answer. So you don't need to show your check, but you need to plug the number back into the argument. Just make sure you get a positive value. Okay, let's look at b. It says the natural log of 2x minus 5 is equal to the natural log of x minus 3. They are both natural logs. They have the same base e. Since they have the same type of log with the same base, it must be true that this argument is equal to this argument. So 2x minus 5 must equal to x minus 3. Okay, now I'm going to go ahead and solve it. What is that? X minus 5 equals negative 3. Oh, I could have canceled the 5 at the first step if I wanted to. So I get x equals 2. Okay, now I'm going to check for extraneous solutions. And I'm mostly checking to make sure the argument remains positive when I plug the 2 in. Okay, so if I take this 2 and I plug it in here, what is that? 2 times 2 is 4. 4 minus 5, that's negative 1. We cannot log negatives. So the 2, even though we solved correctly, is going to make this the log of negative 1, which is not allowed. So even though I solved it right, x cannot equal to 2. So I'm going to say x can't be 2. Since x equals 2 is my only possible answer, in this case there is no solution. Most of the time it will work, but occasionally it will not. So just verify that the argument's positive. If I plugged it in here, actually, 2 minus 3, I would also get negative 1. And since I can't log negatives, it makes it not work. Okay, now there's a second strategy for solving logarithmic equations. The second strategy is by rewriting an exponential form. Okay, so if I look at this one, it says log base 8 of 5x plus 4 equals 2. It doesn't have a log base 8 on this side, so I can't use the equality property of logs. So since there's no log on this side and the log is isolated on this side, I'm going to rewrite this in exponential form. What are we doing? So what is the base? The base is 8. 8 to the exponent to the second equals 5x plus 14. Okay, now I'm going to go ahead and solve it. 5x plus 14. I'm going to put the 64 on this side. You don't have to. I'm just moving it around. So I get 5x equals 50. Let me divide by 5. So I get x equals 10, and I'm pretty confident I did it correctly, but I'm still going to plug it back into the equation, at least mentally, to make sure it's going to be a positive answer. Okay, if I plug 10 in, 5 times 10 is 50. 50 plus 14 is a positive number. As long as it's a positive number, it's going to be a valid argument for my logarithm. Okay, let's look at b. It says the log base 2 of x minus 11 equals 5. Okay, there's no log over here, so I can't use the equality. So I'm going to have to rewrite this in exponential form. So what's the base? The base is 2 to the 5th equals x minus 11. Okay, let me multiply out 2 to the 5th. That's 2, 4, 8, 16, 32. Okay, now let's solve for our x. So I get x equals 43. Okay, I believe I did everything right. So I'm just gonna plug it in real quick. And you can plug it in and check for real, but I'm just gonna make sure this is positive. If I do 43 minus 11, do I get a positive value? Yeah, 43 is way bigger than 11, so it's gonna be a positive value. So that's a valid answer. Okay, let's try one more. I guess this is a trickier one. Okay, it's a log base 3 of x squared plus 2x plus 1 equals 2. There is no log on this side, so I'm gonna have to rewrite this in exponential form. So the base is 3 to the 2. 3 to the 2 equals the argument, which I can already see is a lot of stuff. Okay. 3 to the second power is 9. Okay, this looks okay, but it is quadratic. So I'm gonna get 2 answers probably. It also has this 2x, so I'm gonna probably factor this. So I'm gonna minus the 9 because I think I'm gonna have to factor. I know. 1 minus 9 is negative 8, but now it equals to 0. Okay, so let's go ahead and try to factor this, and hopefully it factors. Okay, to factor, let me look at the last term. What do I times to get 8? 4 times 2. One of them has to be positive, negative. It has to add up to positive 2, so it must be positive 4 minus 2. So my answers are x equals negative 4 and x equals 2. Okay. Even though I solved it correctly, I just need to verify that this is going to produce a positive argument. Okay, when I plug in positive 2, that's going to be positive plus a positive plus a positive. I'm very confident that that's going to be a positive argument. So I think the 2 is valid for sure. The negative 4 is a little trickier. Okay, if I do negative 4 squared, what do I get? I get 16, positive 16. 2 times negative 4 is minus 8 plus 1. Is that going to be positive? Yeah, that's positive. Since I also get a positive argument from the negative 4, it's still a valid answer. When there's 2 answers, you're more likely to get an extraneous solution. Okay, the next page is practice problems. The answers are at the bottom. So pause the video, and then when you're ready, you can unpause and look at my work. Okay, here's my work for the first 2. I did check in my head that it's going to make a positive argument for this one. I don't know what 11 over 5 is. It's 2 point something, but if I do 5 times 2, it's 10 minus 2. That's positive 8. It's going to be a positive. Okay, for number 3, I got x equals negative 14, but when I plugged it in, it made this negative or this negative, so it didn't count as a solution. It was no extraneous. And then for 4, I got x equals 45, and it was a valid answer because the argument was still positive. Okay, for 5, I got x equals negative 5 and x equals 2. I verified by plugging in to make sure we get a positive. 4 plus 12 plus 6 is positive. 25 minus 15 is a positive plus 6, so both answers were valid.